Hello everyone. In this video, we'll be talking about metals reacting with water. So metals reaction with water. Does all the metals react with with water in the same manner? The answer is no. Every metal reacts differently. Some metals react with cold water, some react with hot water, and some react with steam. Not even hot water, it's boiling water, steam that comes out. And some of them don't even react with cold water, hot water, or steam. So let's look into the detailed information about which metal reacts with which form of water and what happens after the reaction. The general reaction of metals with water is that the water will the general reaction of metal with water is that the water is always going to react with metals and it's going to form metal oxide and hydrogen gas. So the general equation is metal with water will always give us metal oxide and hydrogen. So as you can see here, when lithium is put into the water, it's a very vigorous reaction, means the reaction happens very quickly and you can see the bubbles coming up. The bubbles are nothing but the hydrogen gas released. One of the way to test whether the gas released is hydrogen is we bring a lighted candle near the beaker and the flame will go off with a pop sound. Okay, this is sodium. As you can see here, there are some flames. Sodium is the most violently reacting metal. It can make the water catch fire. Even if you drop a piece of sodium in cold water, it can catch fire. Okay, similarly, potassium is violent. You can see the flames more violently coming out compared to sodium, but both of them react very violently with cold water. They also give out hydrogen gas and metal oxide. Now this flame that we say that metals catch fire, it's when sodium or potassium is reacted with water, it catches fire. It's not the sodium or the potassium oxide which produces fire. It's the hydrogen gas. Because of the high heat which is released, the hydrogen gas converts and it catches fire because of the high heat generated during the reaction by the sodium oxide or the potassium oxide increase the temperature of the hydrogen gas and that catches fire. The fire produced is because of the heat produced and the heat heats up the hydrogen and that makes the metal look like it is catching fire, right? Now we'll be looking into this reaction a little bit later. Let's go into general information and then we'll come back individually. So metal reacts with water to produce again metal oxide and hydrogen gas. In many cases, extra energy or enormous amount of energy is also released. So those reactions which release energy are known as exothermic reaction. Okay, so here as I've taken few examples, sodium reacting with water gives us sodium oxide plus hydrogen gas. Zinc with water gives us zinc oxide plus hydrogen gas. Calcium reacting water gives us calcium oxide plus hydrogen gas. Now we need to see each metal reacts with normal water or different forms of water as I have already mentioned. Okay, so first we are going to talk about is whenever the metal oxide which are soluble in water, those metal oxides which are soluble in water are, are allowed to dissolve in water, then they form metal hydroxide. All metal oxides do not dissolve in water, but those metal oxides which dissolve in water, they form metal hydroxide, which is one of the major basics. Okay, so all metals do not react with water. That is also one thing. And all metal oxides do not dissolve in water. Okay, so there are few metal oxides which do dissolve in water and they form their respective metal hydroxide. Okay, as they have shown here, this metal is heated up. So when it is heating, it forms metal oxide. Burning with oxygen always gives us metal oxide. So the metal oxide is melting and it's getting dissolved in water. So what is remaining in the solution or what we get at the solution at the end is metal hydroxide. Okay. Next is metal oxides that which are soluble in water dissolve in it to form metal hydroxide. Those metal oxides which dissolve. So sodium oxide dissolves in water to give us sodium hydroxide, hydrogen and energy. Same way zinc oxide dissolves in water to give zinc hydroxide, hydrogen gas and energy. And calcium oxide also dissolves in water to give us calcium hydroxide, hydrogen gas and energy. All metals again do not react with water or do not dissolve. All metal oxides do not dissolve in water. But those metal oxides which dissolve in water and form metal hydroxide will always form hydrogen gas and energy is released. So it's an exothermic reaction. Okay. So let's come back to individual metals reacting with different forms of water. So as you can see in the picture, sodium is reacting with water and potassium is reacting with water. Both have their own distinct flames and both are having these sparkles coming up and a little bit of a flame. Again, the concept of flame, that the sodium reacting with water generates flame or catches fire. The fire is because the heat which is released during this reaction heats up the hydrogen to that level where it catches fire. So the reaction is so violent and so exothermic that the hydrogen will immediately catch fire. Okay, let's have an experiment, look into the experiment and understand this more clearly. As you can see here, we have taken sodium metal periodic table, which we'll be learning in the next chapter, but we are taking sodium metal in a petri dish and we are going to cut it off with a knife because it's the softest metal that can be cut with a knife. Okay, and then we are going to take some pieces of this sodium and we're going to immerse in water and we'll see what happens. Okay, as you can see, we are taking very tiny pieces of sodium and each piece of sodium which is cut has a very shiny surface. Okay, the remaining pieces are again put back into the kerosene so that we don't want the sodium to get reacted with water, sorry, oxygen, the air present in oxygen present in the air. So first of all, we are testing the water. It is acid of 6. It matches with 6. It's an acid. Okay, correct. Initial test shows pH of 6 of what? The water. Now we are going to add sodium. Can you see the reaction of sodium? Yes, it's very tiny bit of sodium put, therefore the hydrogen release is not catching fire. If the amount is more, then it will catch fire. So you can see sodium plus water gives sodium hydroxide plus hydrogen gas. Okay, now we'll check the pH of this particular solution. And sodium hydroxide is a base, therefore the pH should be more than 7. So can you see? It matches with around 13, 12 or 13, right? So pH test after reacting with sodium metal with water indicates a pH of 14. Okay, so you can see the sodium can catch fire and the pop sound is because hydrogen gas is released, right? So we just saw the reaction of sodium with water and potassium with water. So it's an explosive reaction. Sodium and potassium can react with cold water and they will produce enormous amount of energy. Sodium hydroxide and potassium hydroxide, the two bases will be formed. Hydrogen gas is released and enormous amount of energy is also released. The next violent reaction, not explosive, but it is a very quick reaction which happens, is calcium. It also reacts with cold water. It also forms enormous amount of heat, but the hydrogen gas which is released will not, its temperature will not rise up to that level where it will catch fire. Okay, but it's a very quick reaction, comparatively slower to potassium and sodium, but it's still a violent reaction. Not only that, the calcium starts floating because it sticks to the bubbles of the hydrogen gas which is released. As you can see here, the bubbles of hydrogen gas is released. Now these bubbles are more predominant with the whitish color because it's the sodium which is sticking to the hydrogen bubbles and it's floating to the surface. So calcium starts floating because the bubbles of the hydrogen gas formed get stick to the surface of the metal and it will carry the metal along with it towards the surface. Let's have a look into the experiment. So as you can see here, they have taken a beaker and at the background it's a plastic, so it's not the substance which has been it's not the calcium inside the beaker. Now we'll be putting few calcium powder. Can you see? They have inserted and the bubbles of hydrogen gas are released. Okay, gradually you can see the whitish powder more bigger in size because it's the calcium which is sticking with the bubbles and they are coming up. Can you see? It's getting more whitish and the bubbles are also getting more whitish because it's the calcium powder which is sticking with the bubbles of the hydrogen, and you can see this particular part rising up, right? And it is bigger, it's very fast. Clear? Can you see? Yes. So you can see how calcium sticks to the bubbles of the hydrogen and rises up to the top of the surface of the water. So next we are going to talk about is magnesium, which do not or does not react with cold water at all. It reacts with hot water only. Okay, that too, how do we do it? It's through the hot water steam kind of. So if you can see this arrangement, there is a test tube wherein they have put some magnesium strip. At the end, there is a heat source, cotton soaked. So we have closed it, and through the heat, it is being heated up, right? So it's the hydrogen gas which is coming out. Okay, so we are heating the hot cotton ball, and through that it is heated. Actually, this is magnesium oxide heating the bright color, forming aluminum magnesium oxide. Okay, and reacting with hot water is what magnesium does, and it again floats along with the bubbles of the hydrogen gas and sticks to the surface. Okay, so the right hand side experiment is actually showing what the magnesium reacting with the air and how hydrogen gas is coming out. How do we detect? We see the lighted flame going off. Let's have a look. Now here we have taken 5 test tubes, and each test tube there are different type of metals which will be labeled, and you can have a look into it. Which metal is in which test tube, and then we'll add few drops of water in each test tube, and we'll see how quick or how slow the reaction is for each metal. Okay, and then the second observation that you have to see is the color of the water. So the first one is the aluminum, second is copper, third is iron, fourth is magnesium, and fifth is zinc. Okay, again aluminum, copper, iron, magnesium, zinc. Okay, so let's observe. So we are going to add in some water to each test tube, and then we'll see what happens to the reaction. Aluminum, they have added some water. Now copper. If you closely look into the reaction, there are tiny bubbles which are being released, which will be magnified, and you can see very clearly this is iron, magnesium, and then zinc. Magnesium is the quickest. You can see the bubbles really coming out, right? But other metals we can't see that quicker, but it will be. The production of hydrogen is there. And if you remember aluminum, can you see 1 or 2 drops coming out of the aluminum? But magnesium is the fastest. You can see that among all the 5, magnesium is the fastest. Then it's a zinc. We don't see much changes into the copper and this, right? You can see the bubbles quickly from magnesium. Then it's the, yes, iron. You don't see much because iron doesn't react so easily. Same way the other one, which is copper. Aluminum is doing, but one bit of a bubble is seen, but magnesium is the fastest, correct? So we just saw the magnesium reacting so quickly with the water, and the test tube water changed into whitish color powder, which was moving up along with the bubbles. So that is why the magnesium also starts from magnesium hydroxide, or magnesium oxide to be more precise, starts floating with the bubbles of the hydrogen gas and sticks on the surface. Okay. Next, aluminum, iron, and zinc, they do not react either with cold water or hot water. We just saw that. The test tube didn't do anything. The aluminum, a little bit, 1 or 2 drops, we did see bubbles coming up, but iron, there was no change. Zinc also, there was no change. Okay, but they do react with steam, and they form metal oxide and hydrogen oxide. Okay, so aluminum reacts with steam, iron also reacts with steam, and zinc also reacts with steam. The metals which will never react, those metals which do not react are lead, gold, copper, and silver. So let's quickly recap. Sodium and potassium are the fastest reacting, vigorously reacting, which the reaction is so fast that it releases enormous amount of heat, and due to this heat, hydrogen catches fire. The hydrogen gas which is released catches fire. Then it's the calcium. It is very faster in reacting, but not compared to sodium and potassium, not that much. Then comes the magnesium. Then aluminum. Aluminum is not with cold water. Cold water was sodium and potassium. Then calcium. Aluminum was not with cold water. It was a little bit of a hot water. Calcium was with